In this tutorial, I'll be going to fine-tune our llama tree model using Unsloth. So from the matrix decomposition, we have this final equation. The dataset query is correct, and also we have the context. We could achieve a great result using a fine-tuning approach. Hi guys, it's Wilson's back again. So today I'll discuss about how to solve hallucinations and inaccuracies in LLM in converting a natural user questions to a cipher query language. This is very important for our correct system because if the model fails to generate the correct cipher query, we won't obtain the correct result from our graph database. And without the correct result, we will lack of necessary context for the generation phase, resulting in a poor outcome. In my opinion, the easiest way to overcome this problem is by using a few-shot prompting. I've covered this technique in my previous video, so you can watch and learn from there. However, for a certain use case, I believe that few-shot prompting won't be enough, and that's why we need fine-tuning. As usual, you'll find all the necessary code in the descriptions below, so now let's get started. There are two important things. The first one is data and then methodology. So actually, you can produce your own data manually. However, this will be very time-consuming. A simpler way is to ask LLM to generate it for us, as what Thomas Bratanick has done. It's very cool, so thanks, brother. So we can access his code through this repository. Now let's discuss about the first notebook. In here, we define the model that we want to use. We are using GPT-4, but I believe we could experiment with other model. Then we define 5 categories of query: simple retrieval, complex retrieval, simple iterations, PEFT finding, complex segregation, and also verbose query. And this part is pretty straightforward, just showing about the prompt that we will use for the generation process. Then in this cell, Thomas used several Neo4j data demo. You could review your own data, and if you're curious about how to insert your raw text data into a knowledge graph in Neo4j, do check my previous video. In this case, Thomas is generating pairs of questions for several databases. However, if we need only to generate pairs of questions for our own data, we can simply make a slight adjustment to the process like this. As the result, we can see the example of generated questions like identify the 3 answers with the lowest scores provided to the most fit questions, register type is simple aggregation queries, and the database is Stack Overflow. Then, the next step is to generate a cipher query from the questions that we already have. We define the database schema and also write a prompt. There's some additional instructions like ensure that query checking for non-null, don't use this type of cipher queries, which I think this part is very important. And the rest of the code is just a basic logic to generate a cipher query. Next, let's open the second notebook. Since it processed in a batch, that's why we need a further preprocessing and resulting like this. So we already have the cipher query in here and in the questions, type the database. And the final step in here is a logic to ensure that the generated cipher query is already correct and capable of returning the results, as it indirectly helps us evaluate whether the generated cipher query can indeed be used for the fine-tuning process. The final output will be like this. Now, let's talk about the methodology. There are some ways we could fine-tune the entire model, which means we retrained all of the parameters. The downside is with retraining 100 billion parameter, the computation cost will be explode. Therefore, the solution is parameter efficient fine-tuning, or PEFT. Instead of fine-tune all of the parameter, all of the weight, we will freeze all of the weight. We don't change any internal model parameters. Then we will augment the model with addition trainable parameter. One of well-known PEFT technique is LoRA, low-rank adaptation. Imagine we have a model with 25 parameters shown in this matrix. If we do fine-tune to the entire model, we need to process 25 parameters. Now, using LoRA, the idea is to tracking the chains. We'll have this. So the first matrix in here is the original model weights, and then the second matrix is LoRA weight chains, and the third matrix is fine-tuned model weights. This time, this matrix is freezed. So you probably think, doesn't we just add more parameter? The answer is no, because there's a concept of matrix decomposition. So we could decompose the whole matrix into matrix B multiplied by matrix A, and this we called as rank 1. So from the matrix decomposition, we have these final equations. So the first matrix is freeze, then we just need to process 10 parameters instead of 25 parameters. That's how LoRa makes the fine-tuning process become much more efficient and faster. If you want to learn deeper about LoRa, I have attached the paper link in the description below. In this tutorial, I'll be going to fine-tune our llama tree model using Unsloth. It has been phenomenal lately because of its speed, and if you want to explore further, go to their GitHub repository. Now, let's jump into code. So the first thing that we need to do is to install all of the dependencies that we need for this project. Just run the speed install command, and then we also do initial setup, get the Grok API key, the Hugging Face API, and also set up our Neo4j database. For this tutorial, I'm going to use recommendations data demo. I fill it here, and also this is the URL for the Neo4j labs that you can also use. Next, we define the graph, and also I print the graph schema. Here we can check either we have connected to our Neo4j database or not. We can see the node properties is movie, genre, user, actor, director, and also here is the relationship. So we've already connected. Before we do fine-tuning, let's see the result of using the original llama tree 8 billion parameters, so we have a comparison to check whether our fine-tuning is success or not. I defined the check grok from LangChain, the temperature is 0, and the model is llama tree 8 billion parameter. And also, we are using graph-cypher QA chain from LangChain. In here, we have defined the parameter, which is the graph, and also the LLM is the model from Grok, and also if posted true. Before recording this video, I tested several questions, and to be honest, for me, it's quite good. However, there were some tests that failed, and here I filtered out, for example, of questions where llama tree 8 billion parameter failed. A disclaimer, the context is not to debate whether llama tree is good in generating cypher query or not, but rather I want to share how to optimize our language model so we can achieve a better results. To check the correct answer, we can go to Neo4j Labs. First, we need to connect, and once connected, we can also run query like this. I've already got the correct answer for those 4 questions, so I copy it here so it becomes easier for us to check it later. Next, we run the cell so we can see the result. And as you can see, the first questions, the general cypher query is wrong, and that's why there's no context, so I don't know the answer. And the second question is same. Recently, here's an announcement of new LangChain update. Based on this post, there's a new parameter that we can include while defining a graph named enhance schema, and also validate cypher parameter in graph cypher QA chain to validate the generated cypher. This update is to optimize our pipeline and get a better result. So now let's try and see whether adding these 2 parameters will solve our problem or not. As you can see, adding enhanced schema parameter in here, while we print the graph.schema, it returns more comprehensive explanation like this. For example, the node properties is movies, and the property of movie is the URL, and the type of the URL is string, and here is one of the examples. In the graph cypher QA chain, if we add in the validated cypher parameters, here is the result. The validation process works very well. Like example number 1, it returns blank in the generated cypher because it is not aligned with the defined schema. Out of 4 questions, 3 of our experiments have failed to generate the correct cypher query that aligns with our database schema. Only 1 aligns with the schema, but in fact, it's still incorrect. So we can conclude that using the original llama tree model, with or without adding the enhanced schema and validated cypher parameters, the result still fails, and that's why we need fine-tuning. Now, let's talk about the most important part of this tutorial, which is the fine-tuning using Unsloth. I defined the max second line. In here, I defined 2048, but actually for llama, we can also use 8000, but since our data is not that long, so I think it's enough for our use case. And here, the D-type and load in 4-bit, which is the quantization. We define the Unsloth llama tree 8 billion parameters, so we can run this. If you still remember, I have already explained about LoRa. This part we are utilizing LoRa. The second important part is creating our dataset. So in here we have the prompt, which we will use it for our functioning process and also functioning. If you look at the original notebook, we are utilizing data from Hugging Face, which is alpaca clade. And if you see our claim, the format is like this. So we have two columns. The first one is output, input, and also the instructions. And that's what we'll try to replicate today. Now we are going to use our own data. We have several columns like questions, cipher, type, and many more. So I did a little bit preprocessing. The input is the questions and the output is the generated cipher query that we expected. We can use dataset. We've already this format of dataset, which we have 762 dataset. Here's one of the example of our final dataset that we will use for the fine-tuning process. Once we have already prepared our dataset, so now let's talk about how to train the model. In this setting, we could either set the max steps or num-train of epochs. I highly recommend you to use num-train of epoch for production purpose, since higher epoch means you give a chance for the model to learn longer. In here, I'm using 1 epoch, and now let's see. 1 epoch means 95 steps, and you can see the training loss is decreased and the final training loss in here is 0.08. And it took only 17.75 minutes. Now, let's see the result of our fine-tuned model. In here, we will need inputs, where we pass the instructions, input, and then leave it blank for the output. We also set to CUDA, so we'll use the available GPU during the inference process. Then we use text streamer to tidy up the output so it becomes easier for us to see the result. Next is to save our model. Of course, we don't want to lose our fine-tuned model, and we don't want to load the entire process when needed later, right? We have the options. The first one is local saving. So if you want to save to your local computer, you can run this out. But I decided to online saving to Hugging Face. To save the Hugging Face, you could use model push to hub, and here you define name of the model, and also make sure the token is for write access, and you don't have just click this new token button. Our model is already saved to Hugging Face. You could also check in here. We will load back our fine-tuned model from Hugging Face. I'm using fast language model from Unsloth. Actually, you could use Hugging Face pipeline, but I already tried it took quite a long time, so I'll suggest you to just use Unsloth. This is the same setup as before, and here I define the name of my model. We're going to run using our loaded LoRa weight, and here's the result. Perfect. Finally, let's do an evaluation. Unfortunately, we cannot use Craft Cyber QA chain like initial testing, and as far as this video released, Unsloth is still not supported in LangChain, but I think it will be integrated as soon as possible. I created a simple chain used to generate answer from the context given. I define a prompt with examples. What is the questions and in the context, and this is the help to answer the expected. We still use llama 3 and grok, and this is the chain, and this is one of the examples. I isolated using 4 questions that we have before, and here is the result. So the first question, this is the cyber query which is correct, and we got the answer in here. And for the second questions, the query is also correct, and you have the list of directors. We have directed movie in Spanish language, Alejandro Jodorowsky, Alfonso Abel, and many more. For the third questions, give me 5 movies where a director has also acted. The generated cyber query is correct, and also you have the context, and here are 5 movies where a director has also acted: The Quick Brother, The Golem, The Haunted House, The Bull, and The Goat. Correct. Last but not least is our final questions. List all movies and IMDb rating greater than 5 that have been directed by a director born in China. So this generated cyber query is correct too. We have the context, and the answer is Ricky O, the story of Ricky. Yeah, that's cool. Using llama 3, even only 8 billion parameter, we could achieve a great result using a fine-tuning approach. That's all for today. We have learned the concept of fine-tuning, especially PEFT and LoRa, how to prepare our dataset, and lastly, how to do it using Unsloth. I hope this tutorial is useful for you guys. If you have any questions, thought, or comment, please let me know in the comment sections below. Bye-bye.